Hello student, today we are going to see class 10 physics current electricity revision we are going to see. Okay, so if you like my channel you can subscribe. Okay, first we will see class 10. It is current electricity revision we are going to see. Okay, from beginning we'll start. The first thing, define current. Current is defined as a rate of flow of charge. Okay, very simple. What is a current unit? Ampere. 1 ampere is equal to 1 coulombs by 1 second. Okay, next one. So Q is how many electron is flowing? It's a n number of electron is flowing. Q is equal to Ne. Okay, this is a conductor we are taken. Okay, one terminal is positive, another terminal is negative. It's connected like this. Positive is a defect of electron, negative is excess of electron. So electron will travel from negative terminal to positive terminal. Current will travel from it is a positive to negative. Okay, so current direction which is going to be a positive to negative. Electron direction negative to positive. Okay, so the next question, how many electron is flowing? There are n number of electron. Okay, when the ammeter reads 1 coulombs, now how many electron is flowing? So Q is equal to Ne. Q is equal to Ne. N is equal to Q divided by E. Q is how much? 1 coulombs. Charge of electron 1.6 into 10 power minus 19 coulombs. This is going to be 6.25 into 10 power plus 18 electron. This many electron it has to flow. The charge going to be a 1 coulombs. Next, potential. Okay, potential difference, the difference between the two terminal. Okay, potential is equal to work done per unit charge. Okay, there are two things we are going to say. First one is the potential, second one is the potential difference. What is the potential? Work done bringing a unit positive charge from infinity to one point, somewhere to electric field we are bringing, no, we call potential. Okay, potential difference, no, work done bringing a unit positive charge from one point to another point we can call as a potential difference. Okay, now the voltmeter is required to measure the potential difference. Okay, what is the unit of work done? Unit of work done is going to be unit potential is called unit of potential is called volt, work done is called joules, charge is called coulombs. 1 volt is equal to 1 joule per 1 coulombs. Okay, next we are going to see the Ohm's law. Okay, so see here, so far we learned two formulas. I is equal to Q by T, V is equal to work done by charge. Okay, we'll relate this to so Ohm's Simon only given this formula. Current is directly proportional to the volt. If you remove directly proportional, you will get as a constant always. So resistance times of volt. So R is equal to I is directly proportional to V. So V is directly proportional to I also we can say. If you remove directly proportional, you will get R times of I. So R is called resistance and also it is called equality constant. What is resistance? No, the obstruction offered by the wire. It's created by the proton. Okay, so R is equal to V by I. Atoms. Okay, it's created by the atoms also. What is the unit of resistance? Ohms. What is the unit of potential? We can call as a volt. The unit of current we can call as ampere. 1 ohms is equal to 1 volt by 1 ampere. Okay, state Ohm's law. Ohm's law, when the applied potential difference is directly proportional to the flowing current at constant temperature. Okay, these are the three formulas. Is a very important formula. I will repeat what are the three formulas is very important. See, current is equal to charge by time, volt is equal to work done by charge, resistance is equal to V by I. Okay, so 1 ampere is equal to 1 coulombs by 1 second. 1 volt is equal to 1 joule per coulombs. Okay, same formula you can write. 1 joules is equal to this one, you can take it this also, volt into coulombs. Volt into coulombs will give us a joules. Okay, so what is this unit of resistance? Ohms. 1 ohms is equal to 1 volt by 1 ampere. Okay, these three are the important formulas. Okay, now Ohm's law. If you want to prove the Ohm's law, no, you have to make it as a very very simple circuit. Okay, this is going to be a resistance, or here I connected as a voltmeter. Okay, and here I connected as a ammeter, then I am connecting as a battery, plus minus, then like this we are connecting. If you want, you can connect here. Switch is called closed switch. Okay, so this is a Ohm's law. Okay, so we are applying the voltage, we are checking the flowing current. Okay, so voltage is directly proportional to the current. V is equal to Ri. So V and I directly proportional. No, if you are drawing the graph V versus I, you will get as a straight line. Okay, so this is a graph going to obey the Ohm's law. Okay, it is called linear graph and it is obeys the Ohm's law. Why it obeys Ohm's law? V versus I is directly proportional. Okay, in case graph is like this, no, it is a non-ohmic resistors, not obeys Ohm's law. Okay, non-ohmic resistor. Next, so if I ask you to verify the Ohm's law, no, we are giving the voltage example V and I, or you should make it. Okay, I will give random value. I will take it 1 volt, 2 volt, 3 volt, like that, 4, 5. Okay, accordingly the current also will flow. Okay, but R is become as a constant. Okay, we will take it, this is 2, 2, 4, 6, 8, 10. Example only I am given. Okay, R is equal to V by I. So V is how much? 1. I is how much? 2. 1 by 2, 0.5. Here it's going to be R is equal to V by I. So 2 by 4, so 0.5. 3 by 6, 0.5. 4 by 8, 0.5. 5 by 10, 0.5. This should be a constant. Okay, so like more somewhat, sometime it will little bit changes also will be happen when you are taken as a practical value. Okay, this is going to be verification of Ohm's law. State and verify the Ohm's law. Many times they asked us a question. If I am drawing the graph, no, I will get like this, V versus I. So example 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this side, no, you can make it according to the data. I will give example only. 2, 4, 6, 8, 10. Okay, so graph point will come like this. You can make it as a straight line. Okay, next we have to take the slope. Slope you can take it anywhere. I am taken so exactly 8 and 4 point. Okay, so changing current, how much changing current? So changing current is how much? So see here, it is 8 minus 4 will get us a 4. Okay, same value. Changing voltage. Okay, for 8 how much voltage should be there? It's a 4 volt. Okay, it is a 4. Okay, next it is the next one for 4 ampere 2 volt should be there. Changing voltage, how much? Changing voltage is called 2 volt. Okay, very very simple. Okay, you can when you are drawing an actual graph, you will get exact idea. Okay, so R is equal to V by I. So V is how much? 2. I is how much? 4. So we'll get as a 0.5. Okay, this is what you can do. State and verify the Ohm's law, and also they asked draw the graph and you have to take the slope to find the resistance. Okay, next, what are the 4 factors affecting the resistance? The factor affecting the resistance, it's going to be factors affecting the resistance. Okay, it's a very very simple. There are 4 factors affecting the resistance. First one, length. Second one, area. Third one, nature. Okay, fourth one is a temperature. First we will see how it's going to be. Length is affect. Okay, resistance directly proportional to length. Okay, what is that meaning? If length, more length, no, when the electron is flowing, no, it will offer more resistance. Okay, resistance inversely proportional to area. Okay, more area, no, the electron easily will travel, that give us a less resistance. Okay, inversely proportional. Okay, we'll take it very small road, it's going long distance, no, it will take a lot of time to come out. Okay, it's a very big area, like a very big road. Okay, easily we can come. Okay, that is the difference. See here, when the length increase, resistance will increase. When the length decrease, resistance decrease. When the area increase, resistance decrease. When the area decrease, resistance increase. Inversely proportional. Okay, again the next one, nature. Okay, copper is a good conductor, everybody knows. So good conductor have less resistance, so copper have good conductance. Okay, good conductance. Same thing, wood. We'll take it wood example. would have more resistance because it's a bad conductor. So conductance will be a less. Okay, they asked when explain briefly factor affecting resistance. These are the things you give. Okay, temperature directly will affect with the resistance. If temperature increase, resistance will increase. Okay, so more temperature will give us a more resistance. Okay, one more formula is there. R2 is equal to R1 1 plus alpha T2 minus T1. This is the relation temperature versus resistance. This is for 12th standard. You don't need to memorize this formula. Okay, the next one, I'll give two graphs. We have to find which have the more resistance. See here, V versus I, V versus I, V versus I. Okay, so like this, which one have more resistance? First we'll see which one have more resistance. So V is directly proportional to I. V is equal to Ri. So more volt give the more resistance. So which one have more volt? See here, this is will take it 10 volt and this is will take it as a 8 volt. So this graph, okay, first one A, B. A have more resistance than B. Why A have more resistance than B? Because it have more voltage. More voltage have more resistance because it's directly proportional. Okay, less voltage have less resistance. Okay, so next one, see here, more voltage have more resistance. So resistance of A is greater than resistance of B. That means temperature, more resistance have more temperature also. Temperature of A is greater than temperature of B. Very, very simple. More voltage have more resistance. Okay, you can take it inversely also. Current, more current have less resistance. Okay, because V is equal to IR. So R, take it this side, V by R is equal to I. So I and R inversely proportional. More resistance have less current. Less current have more resistance. So so here have more current, B have less, B have more current, so which have less resistance. Okay, the resistance of B is less than the resistance of A. Why? Because of current is more. Okay, current and resistance inversely proportional, volt and resistance directly proportional. Okay, so TA, resistance A is greater than resistance B. Same way, temperature A is greater than temperature B. More resistance will offer more temperature also. Okay, like that also we can give. Okay, so this is the concept you can learn in exam. You can apply this concept. Okay, next one. Yeah. Next, resistivity formula. Resistivity formula. Very simple. Resistance directly proportional to length, inversely proportional to area. If you remember directly proportional, you will get as a constant. Resistivity times of length by area. Okay. So it is a constant. Whenever you are removing the directly proportional, you should include with the constant. We will get here resistivity as a constant. Okay, area take it this side, length take it this side. RA by L is called rho. Okay, it's a very, very important concept. This is called resistivity. Resistivity. So resistivity is equal to RA by L. Okay, R is a resistance, unit ohms. A is a area, unit meter square. L is a length, unit as a meter. Get cancel. Ohm meter as a unit of resistivity. Okay, what about conductivity? Conductivity is inversely proportional to resistivity. So we'll get as a ohm inverse, meter inverse. Okay, this inversely proportional conductivity. Okay, see here, very, very small things you need to know. Resistance unit is called ohms. Okay, conductance, what about conductance? Conductance 1 by resistance, ohm inverse. Okay, 1 by ohms also. Okay, what about resistivity? Now only we learned resistivity is called rho, unit is called ohm meter. What about conductivity? Conductivity is called sigma 1 by rho, inversely proportional to resistivity, ohm inverse, meter inverse. Okay, next. So this revision will help you for your board exam, class 10 physics. When you are preparing for the board exam, definitely will help you. Okay, this one video will give full electricity revision. Okay, so resistance versus resistivity, very, very small thing. It's a difference you should know. Okay, resistance unit ohms, resistivity unit ohm meter. Okay, resistance abstraction offered by the wire. Resistivity, no formula first we will know. Rho is equal to R. It is R is directly proportional to L, inversely proportional to A. R is equal to rho L by A. So RA by L is equal to rho. So resistance and resistivity same. When the area is 1 meter, 1 meter square, length is 1 meter. Both are same only, but it's called specific resistance. What is the specific resistance? The length and the area remains as the same. Okay, length is 1 meter square, area should be a 1 meter. Okay, sorry, area 1 meter square, length should be 1 meter. That time resistance and resistivity will be equal. What are the factor affecting resistance? Length, area, nature, temperature. What are the factor affecting resistivity? Only length and area. Independent. Length and area is independent. Nature and temperature is dependent. Okay, I'll repeat again. The factor affecting resistance, length, area, nature, temperature. The factor affecting resistivity, only nature and temperature. Okay, length and area independent. Okay, I'll give one example. If I am taken one wire, we stretch double the times. What about the new resistivity? New resistivity have no changes, but resistance will increase. Why resistance is increased? Because length increased. Okay, so the next one. This is a difference between resistance and resistivity. Resistance unit ohm, resistivity unit ohm meter. Okay, this factor is 4 factor: length, area, nature, temperature. This is only 2 factors: nature and temperature. Length and area is independent. Why length and area independent? Because it is a specific resistivity. It's become as a constant. Okay, now I'll give one more problem. The length is stretched double time. Okay, example, the wire is stretched double time. Wire is stretched double time, so resistance will increase double. Okay, because wire is stretched, R is equal to rho L by A. Length is stretched double. No, only this is applicable for stretching problem. So new resistance, length become double, area become half, because stretching, like a chewing gum only, we are stretching. No, length increase, area decrease. Okay, this 2 will go numerator, so R 2 square times of rho L by A. Okay, so this is going to be a old one. The new resistance is going to be 4 times of 2 square times of old resistance. Okay, 2 times if we stretch it, no, the new resistance will become 4 times of old one. Okay, I am taken, it's going to be n times stretched, so length increase n, area decrease n, so we'll get as a new resistance is n square times of old resistance. Okay, in case we are taken 3 times, 3 square how much will get? 9 times the resistance increase. Okay, in case we are stretching 4 times, 4 times 4 square will be 16 times will increase. Okay, so the stretching problem, the resistance will increase. Okay, with n square times. 2 means 4, 4 means it's going to be 16, 5 means 25 times the value will get increase. Okay, next one, energy and power formula. Okay, so energy formula. So energy already we are given one, we have your energy formula here. See here, so we know energy formula. Energy is equal to volt is equal to work done by charge. Volt is equal to work done by charge. So charge, take it this side. So work done is equal to, which is called energy also. Work done is equal to energy, volt into charge. So very simple. Work done is also called as energy. So energy is equal to VQ. We know current is equal to charge by time. Time, take it this side. Charge is equal to current into time. Substitute here. So what we'll get? So energy is equal to VIT. Energy is equal to VIT. Okay, we know Ohm's law. V is equal to IR. Substitute inside. So energy is equal to IRIT. So what will get? I square RT. Energy is equal to I square RT. I is equal to V by R. Ohm's law only. We are substituting. Okay, so energy is equal to V square by R square, R into T. R get cancelled. V square by R into T. Okay, now we know the energy formula. This everything is energy formula. The question can be asked, derive the expression of energy formula. So energy formula, finally we got VQ one formula, VIT another formula, I square RT as another formula, V square by R into T as another formula. Power is equal to energy by time. Remove all the times, will get as a power. VI, I square R, V square by R. Power formula also sometimes they will ask. Okay, now unit of energy joules, unit of power watt. Okay, power is equal to energy by time. Time, take it this side. So power into time will give us a energy. What is the unit of power? Watt. What is the unit of time? Joules. What is the unit of, time is second. What is the unit of energy? Joules. So 1 joule is equal to watt into second. What is 1 watt? 1 watt is equal to joule per second. Okay, very simple. Next, what is 1 kWh? 1 kWh is called kilowatt hour. It's going to be 1000 watt. 1 hour is how much? 3600 second. So it's a 3 0 6 1 2 3 4 5 0 1 2 3 4 5 0. What second, what we can call, what into second, what we can call joules, what into second we can call as a joules. So 3.1 2 3 4 5 6 10 power plus 6 joules. So what is kWh? KWh is a commercial electrical unit. The kWh is going to represent as a energy. Okay, it is going to be a energy. Okay, next they will ask sometimes state Joule's law of heating. Okay, state Joule's law of heating. Very simple formula. See here, this is going to be Joule's law of heating. Lot of formulas is there, no? This only we are going to call as a Joule's law of heating. So energy is equal to I square RT. Energy directly proportional to squaring of current. You have to state squaring of time. Energy directly proportional to resistance. Energy directly proportional to time. Okay, this is what we can call as Joule's law of heating. Okay, this is the most important concept from a 10th standard. Okay, apart from this, resistance in series, resistance in parallel also is there. Okay, first resistance in series derivation. So 3 resistance in series, R1, R2, R3. Okay, I applied as a voltage. In series, no, current is constant. So voltage is not going to be constant. Okay, so I applied 30 volt example, total volt. So here V1, V2, V3, 10 volt will go. Okay, current constant, no, voltage is not a constant. So V total is how much? V1 plus V2 plus V3. According to Ohm's law, V is equal to IR. So IR is equal to IR plus IR plus IR. This is Ohm's law, no. Current is constant. It is R in series, R1, R2, R3. Current you can cancel. So all the current is constant. So I RS is equal to I R1 plus R2 plus R3. All the current is constant. Current in series is equal to R1 plus R2 plus R3. This is a resistance in series. Resistance in parallel, no. Volt become constant. Okay. So 3 resistance in parallel. Example, resistance in parallel. 3 resistance in parallel. Volt become constant. Resistance is not a constant. I applied the voltage. Okay, voltage get divide. Voltage not going to divide. Current going to be divide. Okay. Here I1 current. Here I2 current. Here I3 current. So totally I current will flow. Same I current will come here. So all 3 current will add and come here. So total current is equal to I1 plus I2 plus I3. Ohm's law. V is equal to IR. R is equal to V by I. I is equal to V by R. I is equal to V by R. V by R. V by R plus V by R plus V by R. Voltage is constant. Resistance in parallel. 1, 2, 3. Voltage remains constant. You can cancel. All the voltage you can cancel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. This is a resistance in parallel. Okay. Thank you for watching my channel. If you like my channel, please subscribe. It is a full electricity fast revision we got. Okay. Thank you everyone.